going to get to what makes Zanyu a great individual later. I'm going to dive into the technical part first, just like Warren did. And so, a little bit of background. So, matrix multiply turns out to be this thing you learn in high school, but it turns out to also be very important to scientific computing and to our great delight to machine learning now. Which I guess means we can say you graduated in machine learning. That's where his job is now at Facebook, so that was a good thing. So, it's a fundamental operation of great importance. Okay. And the idea is when you multiply three matrices of size n by n together, the cost of doing so ordinarily is n cubed, order n cubed. And then in 1969, so that's 50 years ago, Volker Strassen proposed an algorithm that instead computes it with order n to the 2.8 exponent. And this triggered decades of research to bring this down further, n to the 2.3 something is, I think, the current record, although I may be wrong. What is it? Is that all right? Okay. So, now that's on the theory side. And then, so if you go to the ultimate authority, you go to Wikipedia, what does it say? In linear algebra, the Strassen algorithm, named after Volker Strassen, is an algorithm for matrix multiplication. It is faster than the standard matrix multiplication and is useful in practice for large matrices. What do we mean by that? It means that matrix multiply is very important, therefore people optimize it so that you get near perfect performance on a modern architecture. And only for very large problems is it the case that if you use Strassen's algorithm, then you get some benefit from it in practice. Or at least that's how I interpret what they say. I don't think that's actually what they meant. All right, so there was a whole bunch of street wisdom about Strassen's algorithm. As a matter of fact, a recent faculty candidate made proclamations about Strassen's algorithm that were just wrong. So, what are they? Well, the conventional wisdom says it's only practical for very large matrices. Zhanyu's work shows that it's practical for small matrices. Okay. Conventional wisdom says that the matrices being multiplied together should be square, n by n. Zhanyu's work shows that it's very practical for something called a rank K update, which means that one of the sizes is very small, and that happens to be a very important shape in scientific computing. Conventional wisdom says it inherently requires substantial additional workspace. You have to take parts of matrices, add them together, and then you need to do the multiply. No, it takes no extra workspace if you do it right. Okay? Conventional wisdom says that you have to pass in workspace because you have a matrix multiply being used as part of your code. It'd be nice to just substitute in a Strassen and get faster performance, but it turns out you have to change the calling sequence. No need to do that either. Conventional wisdom says that it's really hard to get speed up when you use multiple processors. Well, Zanyu did it on processors with more than 80 cores as well as on GPUs and demonstrated practical benefits to performance. Okay, so what do we see here? Backed up by careful experimentation, he debunked 50 years worth of conventional wisdom regarding a result that almost everyone in computer science knows about. Okay. That's worth doing a PhD, right? So, in addition, he's a great human being. He has been an absolute pleasure as a member of our group, which really functions more like a family than a research group. When we did a massive open online course many years ago for the first time, we've done a couple since, we needed people to help out. And on the discussion boards, we asked our students to pick a gender-neutral name so that people wouldn't find out that only 15% were female taking this MOOC, and to make people feel more comfortable. And after much thought, Zanyu decided on the gender-neutral name of worker. And at the time, we didn't realized how appropriate that was, because over the years, we'd come in on the weekend, he'd be there. Come in 9 o'clock at night, he'd be there. Come in at 6 o'clock in the morning. Well, I don't think we ever were in, but I suspect you were here. So here is a guy who just loves research, loves to work, loves to push the limits, and is unintimidated by 50 years worth of street wisdom. And I couldn't imagine someone who deserves a PhD more than you. Congratulations.